So having looked at calculating the sum to n terms of a geometric series and what formula we use for that, what I'm going to do here is I'm going to present you with just a couple of questions based on this. What I'd like you to do is have a read of the questions, pause the video, have a crack at them, and then come back and check your answers with it. So here you go. First two questions are finding the sum of each geometric sequence to a required number of terms. And then the second question, I'm giving you the sum of the first 3 terms and the first 6 terms of a sequence. I want you to find, firstly, the series, so what it looks like, and then the sum of the first 8 terms. So have a crack at the two of them, come back and check your work. So the first question, I've got 9, 15, 25 and so on, and I want to calculate the sum of that to 7 terms. Well, remember, the formula for the sum, Sm, is equal to A, bracket 1 minus r to the n, over 1 minus r. As we said in the previous video, for being able to calculate the sum, we need 3 things. We need to know n, the number of terms, we need to know a, the start, and we need to know r, our common ratio. So the n for this one is 7. We want to up to 7 terms here. The a, the starting term, is just this one here. So in this case it's 9. And then my common ratio, so looking at the ratio of 2 consecutive terms, I've got 15 over 9 to 5 over 3. If I did the next two, I'd get 25 over 15, which would also give me 5 over 3. So there you go, your common ratio in this case is 5/3. All I then have to do is plug it into the formula, stick it in a calculator, and I'm done. So I'd know the sum in the first 7 terms of the sequence is equal to A, so that's our first term, which is 9, times, then in the bracket, 1 take away 5/3 to the power of 7, all over 1 minus 5/3. And as I said, you just plug it in the calculator at this stage, and off you go. Just be careful with this bit. I've seen errors come when people are putting this into a calculator here. They forget the brackets around it, and it'll end up doing 5 to the 7 dividing it by 3. Just be wary of that one when you plug it into the calculator. Either way, when you do, what you should end up getting is 468.753, and it continues on. So to 1 decimal place, you're talking 468.8. So there you go, sum of the first 7 terms of that sequence. That's what you end up getting. So the second question I set you was this sequence here. I've got 1, negative a half, plus a quarter, minus an eighth, and I want to know the sum to 9 terms. Again, it's the exact same formula. Sn equals A, bracket 1 minus r to the n, all over 1 minus r. Same formula as before, and we need the same 3 bits of information as we did before. First thing we need is n, so the number of terms. In this case, we can simply read it off. It's 9. We need A, the starting term. Again, simply read it off. It's 1. And then we also need R, the common ratio. And again, to get that, we do the ratio of 2 consecutive terms. So in this case, if I do negative a half divided by 1, I get negative a half. So there's your common ratio. And you'll get that regardless of which 2 terms you take the ratio of. Now that I've got all the info, plug it all in, and I'm laughing. So your S9, so your sum to 9 terms, is equal to A, so 1, bracket 1 minus R, so 1 minus negative a half to the power of 9, all over 1 minus R, so 1 minus negative a half. Now again, take this, fire it in a calculator, see what you get as an answer for this. What you end up getting out is 0.66796, and then it continues on for a bit. Round that one there, so you may get it to, say, 2 decimal places, so 0.67. So that would be to 2 decimal places. You might get asked for it to 3 significant figures. So if that was the case, it would be 0.068 to 3 significant figures. Just make sure you read the question as to what kind of rounding it wants for those. And just make sure you get a bit of accuracy. Putting 0.7 in, round it to 1 decimal place, that wouldn't be good enough. You have to get a lot more accuracy at this level. The next one I set you was the question that if the sum of the first 3 terms of a geometric sequence is 744 and the sum of the first 6 is 93,744, find firstly the series and then secondly the sum of the first 8 terms of the series. So to answer part A, what we have to do is figure out what information we've got and how we can plug this all together, combine it, and then get a solution. So the first bit here tells me the sum of the first 3 terms, so that will be S3. And what I know is that that then means that A bracket 1 minus r cubed over 1 minus r, I know that that's going to equal 744. Second bit of information is the first 6 terms. So what I know then is the S6, which is the sum of the first 6 terms. That's going to be A bracket 1 minus r to the power of 6 over 1 minus r, which is equal to 93,744. Now, problem with both of these equations is that they've both got 2 variables. So for 2 variables, it would be like simultaneous equations. We need 2 equations to work together. Now, when we had arithmetic sequences, we could just set it up in that same simultaneous equation style and work it through. Here, because it's geometric, it's slightly trickier, and we can't just do it that way. What we have to do in this case then is take the ratio of both the sums, get rid of one of the variables, and then treat it like a format of a quadratic where we look to solve it. So in this case, what that means is I'm going to do S6 divided by S3. And if I do that, and I do this divided by that, what's going to happen is the a's will cancel, and the 1 minus r's as the denominators will cancel, and I'm going to be left with 1 minus r to the power of 6 over 1 minus r cubed equals 93,744 divided by 744, which is 126. What I can then do is multiply this up and over, and I'll end up with 1 minus r to the power of 6 equals 126, take away 126 r cubed. So what I've done is I've got rid of the denominator. Now if this was a quadratic, I'd look to get everything on one side, set it equal to 0, and solve it. So let's try looking at that method here. So if we take all of this across to this side, I'd end up with r to the 6, take away 126 r cubed. I'd then have 126 take away 1, so I'd end up with plus 125 equals 0. If I then factorise it similarly to what I would do with a quadratic, I'd then get my solutions from that. So what I'd end up with is I'd end up with r cubed minus 1, r cubed minus 125, all equal to 0. Now if I take both of these brackets and I solve them, what I end up getting is r cubed equals 1, so r equals 1, and I get r cubed equals 125, so r equals 5. So that's 2 solutions, but we want one sequence. Well, what I can do is I can disregard that r is equal to 1, because if r equals 1, my common ratio is 1, and it doesn't increase or decrease. Remember, we can't have r equal to 1 for a geometric sequence, so in this case I know that r is equal to 5. What I can now do is substitute it into either of these 2 things here, and I should be able to get my a from that. So if I take it and I substitute it into this one here, what I'd end up getting is I'd end up getting a bracket 1 minus 5 cubed all over 1 minus 5, and that equals 744. And if I solve this through here now, so if I take the bottom up, 1 minus 5 is negative 4, and then do 1 minus 5 cubed on the bottom and divide it through, what I end up finding is that a is equal to 24. So for this one here, my geometric series is given by un equals a, so 24 times r to the power of n minus 1 times 5 to the n minus 1. So there you go, that's me got the series. The second thing I want to do now is find the sum of the first 8 terms. So what I want to do is find S8. Well, we're going to use the same formula as we would have here, so the same format as it. So a bracket 1 minus r to the n over 1 minus r. So in this case we know what the a and r are, simply are, so we just substitute them in, job done. We know that a is 24, So it's going to be 24 bracket 1 minus 5 to the power of 8 all over 1 minus 5. What you then have is, once you've done that, you've plugged it all together, stick it in a calculator. What you end up getting is 2343,744. So 2,343,744. So that's the sum of the first 8 terms of that series. So what we've done, we've shown how we can calculate the sum to a certain number of terms, something we hope we could do naturally involving this formula. We've also shown an application of it where we've induced what the format of the series is, and we've then used that to go further in terms of calculating the sum to even higher numbers of terms. We need to be able to do all these skills when working with geometric series and their sums up to a certain number of values when we're doing past papers in work.